So the next speaker goes by the name Benak. You may have also seen him stream on Twitch. He does a lot of good streams on Android hacking, and he has been crushing it with bug bounties as of late when it comes down to doing bug bounties on Android. So let's give it up. Let's get the chat very hyped and ready for Benak to get on and talk about Android hacking.
Hey everyone, this is Kyle Benak, or you might know me as B3NAC on Twitter or B3NACSec on YouTube. I'm very stoked to be giving my Android hacking talk today at VirSecCon2020, so let's get the party started. Here's an overview of the topics I will be discussing today. First, I'll go over my Android hacking workflow. Then I'll move on to export Android components and how to exploit them. Then finally, deep link exploitation. I've been having a lot of fun with deep links lately. I use Android Studio for proof of concept development, emulators to test APKs and install them on the fly. Also check to see if developers leave logging functions in, because these logging functions will print data over the network on ADB. Sometimes it'll leak like API endpoints. It makes it really easy to enumerate mobile endpoints. Next is JADX. I use this to decompile APKs and do source code review really fast. So there's a GUI version and there's also a command line version of JADX. Next, ADB, also known as Android Debug Bridge, is a must-have utility for mobile Android hacking, because what you'll do is you'll install the application, then you'll pull the application that you installed off of your phone to your computer, and then decompile it with a tool like JADX. Objection is really amazing, in my opinion, because you can patch SSL pinning without a rooted device, which also means you don't have to void your warranty. That's always good. Next is Drozer. So this is getting kind of dated, but there's a useful attack surface mapping feature that'll list out all the exported components on that specific application. DB browser for SQLite. This applies mostly to any SQLite databases you find in public directories. You can use this to read any values that are stored in the SQLite database, and as well as seeing if it's password protected or not. Burp Suite I use in combination with Objection after I patch the APK, because after that it's just like proxying a web app. I have custom bash scripts to automate redundant tasks like pulling the APKs off of my cell phone to my PC. And the cell phones I use are my personal Galaxy S10e phone, a J3 Orbit, and an Android Studio emulator. I would recommend, if you need a cheap test phone, a J3 Orbit is like $50 on Amazon. So that's like one P4. You can get a test phone for Android apps. Next, I'm going to go over my Android Recon process. First, I'll look at Android Manifest, because it's basically a blueprint for the Android application. It'll list all exported components. Sometimes there's hard-coded API keys, and there's the deep link schemas will be in the manifest. Secondly, I'll check strings.xml. Developers are encouraged to store strings as references here instead of in the source code. Doesn't mean they don't do it still, but it's a high chance or high probability to find API keys here. FilePath.xml will show you if there's files being saved to public directories that shouldn't be. And I will touch more on that later. And lastly, always search source code recursively, and don't just check the common areas. For example, my last finding in a build config file, there was a pretty awesome API key hidden there. Now I will go over API Key Recon after I show you my methodology in JADX. So after you have Android manifest.xml open, which is over here, I'll close these real quick just so I can show you from scratch. So you click on Android manifest.xml, and from here you can search for exported activities. Exported equals true, and you can see here that flag 12 exported activity is exported. Who would have knew? Now you go to the search want, and you can put in the activity name, and it'll give you the Java class. Double click on this, and then you'll be able to view the source code and see what exactly is going on. So from here, I'll check to see what's in the onCreate method, for example. In this onCreate method, there's a web view being made, and it reads in a variable that can be supplied by the user called totally secure. It checks if it's null. So if the totally secure variable isn't provided, then none of this will happen. But if it is, then I'll check to see if it's HTTPS schema. If it is, then it will go to the host and to whatever host is specified. Else it'll draw it as text HTML on the web view. So from there, after I've checked classes, I'll check strings.xml. There's no really particular order I do this, but it's usually Android manifest and strings.xml first, just to get a good good overview of the app. Now from here, I'll look to see if I can find interesting deep link endpoints or API keys. Once I find an API key, I'll copy the string name, and I'll recursively look for that referenced in any of the other classes. Now once I find it in another class, I'll see if there's any other parameters that are required, and it looks like these are also required. So I would need all these values to get a request to successfully send with like curl or something. And you can see that it looks like it toStrings all these and then sends it. Okay. Now when I look for deep link schemas, I'll look for intent filters. And as you can see here, there is a scheme that doesn't require anything except for just the scheme. And that is for this activity. So this activity, I should be able to send a deep link request to with just the scheme. So during API Key Recon, always verify the key has impact. If you report just the key, it's most likely going to be marked informational, or the triager is going to ask you to show how you can exploit the services based on the key that's exposed. I always like to think of API Recon as a puzzle, and I showed you how you can kind of piece the puzzle together with string resources and how to find the params in the source code. Moving on to export to Android components. So this is one of the main ways to exploit Android apps in general. So a lot of the times you're going to be working with activities because they're entry points for application interactions of components that are specified in Android manifest. One of the easiest callback states is to exploit is onCreate, because when the activity started, onCreate is called. Services apply additional functionality in the background. I would also like to know that these aren't the specific definitions by any means. I just summed them up like this. Broadcast receivers receive broadcasts based on specific events of interest, which are usually specified in the broadcast receiver activity. So when a broadcast receiver is exported, you want to check this activity to see if there's user input that can be supplied. Content providers help applications access stored data, share data with other applications, and yeah, that's pretty much it. Now, how to exploit Android activities. So you can access protected intents via exported activities if the export activity allows you to execute an intent based on a user provided one. And I'll show you what I mean by that. It's kind of like intentception. One exported activity that accepts a user provided intent can expose protected intents. Access to sensitive data via the export activity. There's a lot of ways to do this, but often it's combined with deep links to steal data, or involves writing session tokens to an external file or exfiltrating a database to external, like malicious database. Accessing sensitive files, stealing files, and replacing imported files via export activities. One of the main things you need to check for, if you find a state changing deep link, for example, that downloads a sensitive file, is to see if that file is being saved to a public directory, and you can see that in files path.xml, and if external file paths or external path is specified, it's being saved publicly. Access to protected intents via exported activities. So this is a vulnerable code sample that shows that it looks for a intent that's attacker specified, and if the deep link isn't null and the deep link exists somewhere else in the application, it will start that intent and is no longer protected. This is like a door to the entire application, basically. Exploitation of Android services. This is using a third-party upload service that allows you to specify your own server and add a file that is saved to a public directory, and then send it with an intent to your server. The main reason this is vulnerable is because exported equaled true, and it accepted user provided input. Exploitation of Android broadcast receivers. So this is also vulnerable when the receiver is exported and accepts user provided broadcasts. One of the things you want to check for is like if get string extra is reading in a specific variable. You can test this with ADB. You just have to know the intent name to send, and you can put the --es flag for every variable that's reading in, and provide whatever data you want. And I also included a Java POC because it's helpful to provide multiple POCs sometimes for the developers. Exploitation of Android content providers. So I found a few ways that these can be exploited. Content providers that connect to SQLite can be exploited via SQL injection by third-party apps. It's easier, in my opinion, to do this with Drozer and while using the projection flag. There was a very interesting case where a content provider only checked the class names and compared them to a list, which meant this is very easy to do, and you can create an app that spoofs the name, and you can spoof the activity of the accepted that is on the accepted list. So, for example, if com app spoofed activity was on that list that was accepted, all I have to do is create an app called com.app, and then I can create that activity and send a request upon the main app, and the logic is going to accept that and think that it's coming from the valid app. And this was because the grant URI permissions equaled true, and it was only checking based on a list. What is a deep link? So a deep link takes a user to a specific destination within an app. So I like to think of as deep links as Android URLs to specific parts of the application. Usually mirrors web application, except with a different schema. So there are some more secure ways to implement deep link schemas, and you can specify a schema, host, and then the specific endpoint, and this will make it a lot less susceptible to exploitation. Only thing with this is that if this is still a state changing deep link, it doesn't really help. And what I mean by state changing deep link is if it modifies anything in a user's account, it can still be targeted by CSRF. Verified deep links can only use HTTP and HTTPS schemas. But for testing purposes, sometimes developers keep custom schemas. And I bold this because I have found an entire HTML file full of deep link tests, which helped me greatly in exploiting a very secure application. So the types of vulnerabilities that in deep links are based on how the scheme, host, and parameters are validated. Now, this is an example of an intent filter that only specifies the scheme. This is what you want to see when you're trying to find deep link vulnerabilities. So this is how I test for each of these common vulnerabilities. So CSRF, I test when auto verify doesn't equal true because it doesn't prompt the user. If there's a user prompt at any time, the likelihood of it being successful, it goes down a lot. Open redirect, I test when custom schemes do not verify endpoint parameters or hosts, because depending on the logic, either of these could be possible. XSS, I test when the endpoint parameters or hosts are not validated, and also check if there's a JavaScript interface present or set JavaScript is equal true in the web view. LFIs, I recently found that it was possible to look up files on the mobile device when the deep link parameters weren't validated. Deep link CSRF. Okay, so developers try to take shortcuts sometimes, and what happens is that they'll create a state changing deep link, and these state changing deep links will allow you to pull off CSRF and modify user profile settings and etc. Or in my case, I was able to download a file automatically from the user's account. All deep links are GET request and should be verified. Auto verify equals true. With auto verify, it makes it a lot more secure because it's making sure, for one, that the deep link request isn't coming from a third-party app, and two, it's using a secure schema that will prompt the user. It asks them if they want to open in the browser or the verified app. So here are some deep link CSRF examples. So you can literally save an HTML file with a deep link and push it to your mobile device and click on that HTML file or that link in the HTML file, and it will execute the deep link on the app itself. There's also a way to do it with Java third-party apps, and I've included that also because, once again, it's always good to have multiple proof of concepts. And then finally, in this case, I was showing that I could get a sensitive file, and then exfiltrate it with intent extra stream. from a public directory. Deep link open redirects. Okay, these are fun, but you always want to try to chain these together with something else. So a schema and an intent filter only specified in Android manifest is what you want to look for. In this case, you can see flag 11 is only specified. You want to further investigate the activity class, and in this case, it was deep link activity. And it only requires a specific protocol, which is flag 11. And one unique case that could happen is custom schema may be converted to match a web protocol. So with this code example, as long as I have flag 11, it will pass into this if statement, which will convert it from flag 11 to HTTPS, and whatever host I specify will be executed, and with this intent on the bottom. So I do have an example to show you for this. So now I'll go to my deep link activity, and as you can see, all I have to do is send an intent that gets the flag 11 schema and converts it. Now if I go to my emulator, I can exploit this with ADB command. And as you can see, it open redirected to google.com. And what this command does is it starts an intent as a view action, and the -d parameter feeds it the schema with the host of google.com. Any host I put in there, it will redirect to. And here's a couple more deep link open redirect examples. I just showed you the ADB one. I'll show you the HTML one now too. This is exactly what you can push to your phone. It's it's just an HTML document that has a test open redirect payload and a XSS payload. And now I'll show you how to push it to your device. To push it to your device, you're going to want to use ADB push, the file name. Make sure you're in the directory where the file is, or you can do the absolute path. And then the path to your download directory. In my case, well, this has worked on my Galaxy phones and my emulator. So you can see that it was successfully pushed to my device. And I'll navigate to my downloads, and you can see here's my HTML payload, or my HTML file with a payload in it. Let me zoom in real quick. And now if I click on one of these links, it will have the same effect. And boom, there you go. Moving on to deep link XSS. So it's possible if schema, host, and URL parameters aren't validated. Some cases, if the host or the schema is not validated, JavaScript alert will work. You always want to look for add JavaScript interfaces, and if set JavaScript enabled equals true. Android doesn't enable JavaScript by default. So when a mobile application needs to interact with a web application, this is where JavaScript is sometimes enabled for compatibility with web views. So when you see a web view, always check for JavaScript interfaces and JavaScript enabled. As you can see here, I explain what a defined web view looks like in Java, and what the user supplied data could be, which is a get string extra. And here's a deep link example. So once again, this can be done with Java, or it can be done with a deep link. And this isn't only limited to if a host isn't validated. You should also test parameters. If you find a specific deep link takes parameters, always test various vulnerabilities with it, because you never know what the logic is like. Also, if it's a verified deep link, you should still test for vulnerabilities, because it could execute on the server side through the mobile app. So now I will show you an XSS example with a proof of concept app. As you can see here, here's a vulnerable Java class, and I will zoom in because, wow, that is not very readable. Okay, so Android Studio even warns developers, like, you set JavaScript enabled, can't introduce XSS vulnerabilities into your application. In this case, it's definitely true, because once I set it to enabled, I use a web Chrome client, and in this logic, I draw the payload to text.html. So let me open my emulator real quick, and I'll X out of all this stuff. And so I also have a POC app I'll show you. So in this POC, this is all that's needed. You set the class name to the vulnerable class. You find the variable that is reading the data in, and you provide the data. And then you start the activity with the intent provided. So if I go to my POC, which is right here, and I execute it, it'll send the intent and execute it in the main app. Deep link LFIs. So this was like really fun to research and super interesting, and I am super excited to share this with everyone. So try on custom schemas and verified scheme parameters, because like I said before, it could execute on the server side. Verified schemes such as you might look up server files from the mobile application depending on implementation, and that goes back to how the logic is coded. So when you're doing recon and you check file path to XML, see if there is a external file path that it's saving to, because this makes it a higher chance that you're going to be able to look up a file on the device itself remotely. And I want to reiterate that the two keywords in XML that is going to let you know it's an unsafe path is external files path and an external path. And the path equals app data is what the file name is going to be on the device that the files are being saved to. Use directories within internal storage to save sensitive information that other apps shouldn't access. This is very important. So when it's sensitive information and it's saved to external directories, that's when bad things can happen. All applications can access those files on the mobile device. Deep links can be used to exfiltrate specific files. Files can be uploaded via streaming intents. So here's an example that I used in one of my POCs recently, that I showed I could exfiltrate a file via email with a stream intent. Here's a list of public Android directories. So if an application saves to any of these public directories, it's bad news. But it's good news for you because then you can like report it if you can get an LFI. Deep link LFI example. So this is a method I use to search folders recursively for PDF files because in my case, the vulnerability works specifically with PDF files. So this method basically destroyed all PDF files in the directory. Because the behavior was that if the LFI would look it up, it would only read a certain amount of bytes in, and then it would save over the file, making the file unusable. I also included a proof of concept with HTML at the bottom, where you can see I used the same exact thing that I had in same exact path in deep link, except for I provided the specific file to the deep link. This is very effective when there's a specific file with a lot of sensitive data. Here are my resources for my talk. I hope you enjoyed my talk on Android hacking. And I want to thank Ben for inviting me to talk at VirSecCon2020. It was a blast. Until next time, everyone.
All right, Chad, give it up one more time for Kyle, aka Benak. What an amazing talk. Definitely a lot to learn from. All right, Chad, give it up. I keep on forgetting to turn off my volume in the background. Anyways, thank you again for doing this, Kyle. We appreciate it.